All right, so we figured out what a short-run equilibrium for a competitive firm looks like. What I want to do is to go through four separate cases that constitute the entirety of what a short-run equilibrium can look like. There are four different possibilities for what a short-run equilibrium could be. So we'll get the camera back on the paper here. And so um, what we established before is that the firm always is going to want to produce where marginal cost equals marginal revenue. And we're going to look at four separate cases, four separate possibilities of what that can look like. So in each case, we'll put dollars on the vertical axis and quantities on the horizontal axis. And we'll put the market to the left and the firm to the right. And so one possibility is that we have a situation like this one, where the market equilibrium Q star individual, the price for the market is P star. Each firm then in the market simply accepts P star as its equilibrium price, and that defines the firm's demand, marginal, and average revenue curves. Okay. So one possibility is that the firm has cost curves that look like this. Let's call that average total cost. And average variable cost. And let's see. And there's our marginal cost. And so we ask, how much should this firm produce? Well, the answer is it should always produce where marginal cost equals marginal revenue. So it should produce this quantity. And this looks just like the picture we did in the last segment. Now we need to figure out where the firm stands. So this height at Q star, that's a relevant quantity, the height up to the demand curve shows the firm's revenue per unit, its average revenue. So this height is the firm's average revenue. That's how much revenue comes in with each unit it sells. And the average total cost curve shows the firm's average total cost at Q star. The difference between those two, that is this vertical distance right here, that is the firm's profit per unit. Right? The difference between its revenue per unit and its cost per unit, this height right here is the firm's average profit. Alternatively, we can look at it this way. We can say, well, if this height is the firm's revenue per unit, the revenue per unit times the number of units will give us total revenue. So this entire area is total revenue. This area is the firm's total cost. So this right here is quantity times average cost, which gives us total cost. And right in here then is the firm's total profit. The height is the profit per unit. The height here is the profit per unit, but the entire rectangle is the profit per unit times the number of units, and that gives us total profit equal to that rectangle. And so this is a firm whose revenue is above its costs. Its revenue per unit is above its cost per unit. And so this firm earns an economic profit in the short run. And so we will call this situation profit maximization. So that's one possibility. that the firm in the short run earns an economic profit. Let's try a second possibility. Again, the supply and demand determine equilibrium price and quantity. Label those axes. And so we get equilibrium price and quantity. The firm accepts the market price at P star, and that means the firm's demand, marginal, and average revenue look like that. Now suppose that the firm's costs look like this. Here's going to be the average total cost. Total cost. Here's the average variable cost. And here's the marginal cost. So we ask, what's the firm's optimal quantity? Well, the optimal quantity, the quantity that puts the firm at greatest advantage, is always going to be where marginal cost equals marginal revenue. And so this is the firm's optimal quantity. Now we take a step back and ask, how is the firm actually doing? And the answer is not so well. The firm's revenue per unit, again, is given by the height of the demand curve at Q star. So this is the firm's revenue per unit, or average revenue. But we have to go all the way up to the cost curve to find the firm's average total cost per unit. And you can see that the cost per unit is greater than the revenue per unit. And so in this case, the firm is actually incurring a loss. If we just extend this box over, we can see that this area, the area that represents the excess of total cost over total revenue, this is a firm's loss. And the question is, what should the firm do in this situation? In this case, the firm's loss is this amount. We have to ask, how much would it lose if it shut down? And the answer is that it would lose this much per unit, that is its fixed cost. So if the firm shuts down, it still has to pay its insurance, it still has to pay property taxes, you may have to pay a lease, you have to keep paying off the bank. Whatever obligations the firm has, in the short run, those obligations continue. And so this would be the firm's loss if it were to shut down. That's its loss per unit, and the total loss then would be this area, which represents the firm's total fixed cost. So the total fixed cost, this entire area, is larger than the firm's loss if it stays open. So the logic is that the firm should stay open in this case because its loss staying open is greater than the loss it would incur if it shut down. And so this is a case that we refer to as loss minimization. In loss minimization, the firm stays open, losing money in the short run. Presumably, if nothing changes, when the firm gets to the long run, when the bank bill's paid off, when they have no more fixed obligations, then the firm would shut down if it's still losing money. So profit maximization, loss minimization, those are two cases. I know you're impressed with how prepared I am for this. All right, two more cases. Again, there's a demand and supply in the market, and those determine equilibrium quantity for the market and the equilibrium price. Typical firm simply accepts that price, and that defines the firm's demand, marginal, and average revenue. Now suppose the firm's costs look like this. Here's average total cost, average marginal cost, average variable cost, and marginal cost. How much did the firm produce? Well, its optimal quantity is where marginal cost equals marginal revenue. In this case, the firm's revenue per unit is less than its cost per unit. So again, the firm is losing money. But what's different is that now the average variable cost is above the demand curve. That means that if the firm stays open, it's going to have a loss per unit equal to this entire distance and a total loss equal to this entire rectangle. Whereas if the firm shuts down, its loss will be only its fixed cost, which is this area. It's a smaller area than its loss if it stays open. The loss if it stays open is this. And so in this case, when the average variable cost is above the demand curve, the firm should shut down. And that's what we call this case. This is the shutdown case. The final case is this one. Demand and supply determine equilibrium quantity for the market and the equilibrium price. The firm accepts that equilibrium price. And that price determines the firm's demand, marginal, and average revenue. Now, suppose average total cost looks like this. The average variable cost looks like that. And marginal cost looks like that. How much should the firm produce? Well, it should produce the quantity at which marginal cost equals marginal revenue. This is the firm's optimal quantity. How is the firm doing? Well, its revenue per unit is exactly the same as its cost per unit. And so in this case, the firm is earning zero economic profit, or we would say that this firm is just earning a normal profit. So we will refer to this case as the case of a firm earning a normal profit. And those are the four potential cases of short-run equilibrium for a competitive firm. The firm could be earning an economic profit, maximizing profit. It could be losing money but still stay open, loss minimization. It could be losing money but loses so much that it's better off to shut down. Or it could just be earning a normal profit. Those are all four possibilities. In the next segment, we'll talk about what long-run equilibrium looks like.